Hi everyone, today we're going to study Cramer's Rule for 2 by 2 linear system of equations. We shall see how the determinant can be used to solve a system of linear equations. By definition, a system of linear equations is said to be consistent if the system has at least one solution. And the system is said to be inconsistent if no solution exists. Here we have three examples. The first example, x plus y equals 5 and x minus y equals 3. We can solve for the values x and y, and we will find that x equals 4 and y equals 1. Here we say that there is a unique solution. Therefore, this system is consistent. If we're going to graph the two equations, we will find that these are two intersecting lines. Now, example 2. 2x plus 3y equals 8. 4x plus 6y equals 16. If we solve for x and y, we will see that x equals k and y equals 8 minus 2k over 3. We can put any value for k. Then another value will come for the y, which means we have infinite number of solutions. But then this is called consistent system. If we're going to graph the two equations here, we will see that we have two coincident lines. Example C, 2x plus 3y equals 8, 4x plus 6y equals 15. If we solve for x and y, we will find that there is no solution. Because of that, we will call this system as inconsistent. If we're going to graph the two equations, we will see that these are two parallel lines. Let's go to Kramers Rule. If A is a non-singular n by n matrix, that is, determinant of A is not equal to 0, then the linear system capital A times capital X equals capital B of n linear equations with n unknowns, x sub 1, x sub 2, x sub 3, up to x sub n, has unique solution. The solution is x sub 1 equals determinant of a sub 1 over determinant of a. X sub 2 equals determinant of a sub 2 over determinant of a. Up to x sub n is equal to determinant of a sub n all over determinant of a, where a sub j is the matrix obtained by replacing the entries in the jth column of A by the entries in the matrix B, or the matrix of constants. Take note that Cramer's rule does not apply if determinant of A is equal to 0. Let's go now to Cramer's rule of 2 by 2 system. Consider the linear system of equations a sub 1 x plus b sub 1 y equals d sub 1, a sub 2 x plus b sub 2 y equals d sub 2, where x and y are unknowns. This system can be written as in matrix form. We have the matrix for the constants a sub 1, b sub 1, a sub 2, b sub 2. Then we have the matrix for the variables, the column matrix xy equals, we have the matrix for the constants. This is the column matrix d sub 1, d sub 2. And this is the same with ax equals b. A here is the matrix for the constants, x is the matrix for the variables, b is the matrix for the constants. With determinant of a not equal to 0, we have now this formula to get the values of the unknowns. For the x, this is equal to determinant of a sub 1 over determinant of a. And the variable y is equal to determinant of a sub 2 over determinant of a. Remember, a sub 1 or the matrix a sub 1 is equal to d sub 1, b sub 1, d sub 2, b sub 2. And the matrix a sub 2 is equal to a sub 1, d sub 1, a sub 2, d sub 2 respectively. This is our working formula. Example, use Cramer's rule to solve the following system of linear equations. 5x plus 2y equals 4, 7x plus 3y equals 5. Let us write the corresponding matrices. Matrix A equals 5, 2, 7, 3 respectively. Matrix X equals the column matrix XY. Matrix B equals the column matrix of constants 4, 5 respectively. Let us compute the determinant of A. So this is 5 times 3, 15, minus 7 times 2, 14. 15 minus 14 is equal to 1, and we say that, of course, this is not equal to 0. Therefore, the values of x and y are defined. First, let us compute for the x. This is equal to determinant of a sub 1 over determinant of a. First, let us copy the matrix A in the denominator. It will be like this. And for the matrix A sub 1, we will have like this. It is almost the same with the matrix A except the first column. And that is, we replaced by the constants here. Then let us evaluate the corresponding determinants. 4 times 3 is 12, minus 5 times 2 is 10. All over, 5 times 3, 15, 7 times 2, 14. Simplifying, we have now 2 over 1 or equal to 2. This is the value of x. For variable y, this is equal to determinant of a sub 2 over determinant of a. First thing is, we can copy the matrix of A here. And for the A sub 2 matrix, we have like this. It is almost the same with the matrix A except the column 2. We will replace this by the elements of matrix B. Then let us evaluate the corresponding determinants. 5 times 5, 25, minus 7 times 4, 28. Over 5 times 3 is 15, minus 7 times 2, 14. We can simplify further into negative 3 over 1 or negative 3. This is the value of y. I hope you learned something from this video. See you again next time.